Hello, everyone, and welcome to the Biochar Technology Podcast from the International Biochar Initiative. My name is Akio Enders, and today we're joined by ARTi, ARTi, which stands for Advanced Renewable Technology International. And from your website, it seems that ARTi's got quite a lot going on, both in the realm of biochar producing technology, as well as biochar containing products. The technology, from what I've seen or from what I've gleaned, is based on the multimodal shipping container, which is really cool. What else did I find out? So modular system within each of these shipping containers, up to 5 units, each accepting up to 8 tons of feedstock per day, which is quite respectable. But, enough of me. This is an interview, so maybe I should stop talking. And so maybe first, before we start talking about the technology, let's get to know about you guys. So here's my question. What got you interested in biochar, and when was that?
Akio, thank you for your interest, first of all, and your support in the biochar industry. I'm Bernie Del Campo. I'm the president of ARTi. I started this company several years ago, 10 years ago, actually. And well, we have been growing, getting our team stronger and more motivated and, just ready to roll the biochar industry. So we got, I would say, the original founders of the company were Matt Kiefer, Juan Proano, Edson Bendrusculo, Dan Wilson, and me. We started in a lab in Iowa State, and from there we started doing some research in thermochemical conversion, just playing with fire, literally getting bio-oils and getting char, that at that point was a co-product, more like a waste than anything else. And well, the idea was from Iowa State to enhance the bio-oil production. From our perspective, we were missing the larger point, which was the carbon in the biochar. So we really got interested after we start playing with equipment, with reactors in Iowa State, seeing what it can be done and understanding more the biochar, the solid waste at that point. So that really got us interested, and absolutely playing with fire. Who doesn't like playing with fire? So,
what did that first reactor look like?
Well, Iowa State at that point had 3 small, we call it pilot reactors, which are 100 grams an hour, maybe a kilogram of an hour of biomass production. And then in Iowa State also there's a big bioresearch farm, and in that one they're bigger equipment, but still bigger in terms of lab. One was a gasification equipment, and the other one was a pyrolysis. And they were for not even a ton of biomass processing per day, each of them. So they were scale, I would say, pilot and demo. Those are the scale we work with.
That's great. Well, it seems like you've learned quite a bit from those as the scale has increased by orders of magnitude since then, which is pretty fantastic. And where's your company based?
Well, we are based in USA, in Iowa, and more specifically in Prairie City. So that's a small town east of Des Moines, 10 minutes from Des Moines.
All right. And your pyrolysis reactors have been dispersed across the world. Is that correct? That
is correct. Our first equipment we manufactured in 2014, I believe. And from then on, we start making 1 or 2 every year. And well, currently we have around 12 reactors spread in different places around the world.
Excellent. And that 2014 reactor, I mean, that brings us to what, 8 years? Did that provide any learning examples, or had you guys gotten the technology figured out before then?
I would say there's no such a thing of figured out this technology because every client is different. Every biomass is, it's challenging in its own way. So there's always modifications and things that we learn in the process. So every installation is a bit different. Every equipment is a bit different. Every product is a bit different. So we're always learning. I would say that's one of our strength from the company, is that we do R&D, we do the manufacturing, and we develop the product. So the combination of those three-legged stool makes us pretty strong in the biochar industry.
Good to hear. Flexibility is nice. In our previous interviews, a lot of this was focused on, or at least a couple of them have been focused on, strictly wood feedstock, and coming from the bioenergy sector into the biochar sector. So it's nice to hear that you can accept a wider range of feedstock, because I'm sure that's challenging, especially as the inorganics increase and as the moisture of the feedstock increases. Yeah, it gets finicky.
Absolutely. And Akio, on along those lines, what we like to say in our company, which might not be entirely true, but if there's carbon and energy, we can make biochar.
Right.
The broad spectrum of materials, waste and not waste, that it can be turned into biochar, they're pretty large. And we have processed, 50 to 100 different materials in all shape and form. So that is, it's holding true. You can do. The major question that the client has and that we have is, can we make a good product? Can you make it sustainably? Can you make it so it generates a revenue? So can you build that equipment for that particular situation? And that is the real challenge.
You're providing some product consultation or feasibility assessment so that folks who maybe have completely unsuitable feedstock, that they don't get too deep into things before realizing that it's just not going to work.
Exactly. And we always start small and, like a research approach. You go bench scale, then you do pilot, then you do demo, then you go industrial. And when clients come, we start with small samples and we play with that and we understand the process and the product. After we do that, we bring the numbers up and we steer those numbers to get the best of the system. And once we know which is the best system, then we start the manufacturing.
Where would you hope to see ARTi in the next 3 to 5 years?
In the moon.
Ah, yes.
All over the world.
Great.
Absolutely. We want our footprint, it has to be worldwide. And we're pushing strongly in the organization of us and also reaching clients all over the world. And we hope to be an international reference in this industry.
And what of these biochar containing products that I've seen on your website, is this secondary? Is this secondary to the biochar producing technology side of things? Or does this just represent, a possible income? Yeah.
All right. Let me ask you, what do you mean by secondary? If you're talking about in terms of revenue or in terms of dedication?
I guess what I was referring to was the focus of the company. And really, there's no need for there to be a dichotomy. It's just a point of curiosity.
Well, the company, we're a startup, we're a small company. And we've been doing a little bit of everything. The first year was, I would say, research and development, because we got a grant from the DOE. And some other years, the manufacturing really picked up. And some other years, our consultation really picked up. And now the biochar, it's I wouldn't say really picked up, but it's a significant source of revenue and activity for us. But honestly, every year has been a little different. But the equipment is a significant source of revenue. And to sell an equipment, in general, we go through a phase of R&D, which it could be a nice endeavor and a significant amount of money.
Great. I feel like I've got an idea of ARTi as a company. Now, could we talk about your technology specifically? Can we dig a little deeper into that side of things?
For sure, Akio, that would be me. I am one of the carbon and economics managers at ARTi, so for sure we can start doing. Regarding the technology, our reactor is mainly based on a slow pyrolysis. How we start on the pyrolysis? Well, our technology mainly works with a minimum amount of propane, just for startup and for stabilizing the temperatures. On the side of biomass, we do pretreat it, and we do manufacture and design equipment for pretreatment if there is the need to, right? Drying, grinding, we have it to be ready and to enter our pyrolysis chambers in that way. Our temperatures mainly range between the 400 and 700 Celsius, but we do have many options for clients. And as Bernie told previously, we have that capability of adapting. So we do use different materials if we can reach or need to reach higher temperatures on that side. The heat, it's mainly based on the combustion of the pyrolysis gases. And how we use these gases after combusting them is we recirculate them into the system to keep up the temperatures stable in the chambers and also into the dryers.
Excellent. I imagine the feedstock is, I mean, of course, it has to make its way from the input to the output side of things. Is it also mixed or agitated while it's inside the reactor?
On that side, it's actually a conveying system process. For example, on the inside, when we start with the process, we have this developed complete automation system. So we do have it from the infeed system. We use kind of walking floor trailers. Then it enters into the system, conveying it. We do not agitate it, actually.
Okay.
When it's out of the reactor, also with some with our technology, we do have also an automatic packaging system. So it's kind of once we have it on site, we use it, we implement the system to feed the reactor automatically, and then the biochar is also packed automatically in that way as well.
Nifty. I mean, one thing that I saw, and that's probably because I just, I don't know, I have a penchant for these shipping containers. Your units are packaged inside shipping containers. Does that mean that they're built on site in Prairie City, Iowa, or wherever else, and then shipped as a complete, already commissioned package?
Yes, that's right. That's the main idea of using the container as units to get that advantage of the container itself and get that advantage of the mobility. So our kind of smallest unit, saying so, the single train unit that we have, and up to the highest capacity unit, all of them are packed in a shipping container. So do you have that advantage of having the structure of it into the shipping container and that advantage also for transportation?
Real quick, on the website, I saw there's an image of a box truck with what looked like a trough and a conveyor, like a hopper and a conveyor into the ARTi container system. Could you talk about that?
Yes, absolutely, yeah. So that is actually what how we implement the system. That's kind of our walking floor trailer system, right? Having the biomass in the truck and then feeding it automatically into the containerized unit from there. That's one of the suggestions that we have, and it's one of the options. But one of our key strengths as well is kind of working closely with the customer and the client. And if they have a different operation, we can adapt to that operation. So really useful, actually. But if the client wants or has a different facility, we usually adapt to their operation.
Great. So it sounds like biochar is certainly the primary product. And then also there's the option for taking off heat. I suppose this is after the reactor has satisfied its heating needs and whatever feedstock drying has satisfied its heating needs. Is there additional heat energy takeoff from these units?
Yeah, for sure. So yes, solid biochar is and its production. It's one of our main focus, but one of the key strengths also is the amount of waste heat that you will have from the reactor itself. So yeah, so it would definitely depend on the feedstock and in every particular operation of the client, but we do have plenty of heat. And on that side, it usually depends on what you would like the heat to be used for, right? So we have seen clients interested in drying, we have seen clients interested in heating, and even in electric generation, right? In power. So that's all kind of the different applications that we have for that waste heat, and there are many advantages for it. We have seen lots of savings as well for clients by using the system, savings on natural gas, for example, by kind of substituting the current system with a pyrolysis unit as well.
Cool. So could we talk about feedstock now? It sounds like no feedstock limitation. Well, certainly some feedstock limitations, but I guess it all depends on how hard you're willing to try. Could you give me some examples of the weirdo feedstocks that you've processed?
Maybe I can jump in. Hey, Akio, I'm Lucette, and also carbon and economics manager in ARTi. So regarding the pixels, actually, it's kind of crazy all the type of pixels that we have parallelized during these couple of months. For example, starting with manure, daily manure, horse manure, syrup, fiber cake, nutshells, sunflower hulls. Well, those are a couple of pixels that comes to my mind. But actually, as Bernie said, every pixel that has energy, we can parallelize it and also carbon as well. So based on that is actually a journey that we love this type of challenges. Actually, we are trying to develop a project for greater ties and also trying to parallelize slopes. So it's kind of crazy.
So it sounds like bring me your piles of biomass and you'll find us, you'll work the system.
Yeah, that's the main idea. We try to parallelize it, as Bernie said, doing a couple of trials in a small scale, then we jump to a bigger scale. And it's trying to know more about the properties of that biomass and also the challenges that we are going to face during the production of the biochar. So based on that, we send it to analyze to a lab, trying to get the moisture content, the ashes, the HOC, the organic seed. That's really important for the carbon sequestration.
I mean, to summarize then, the throughput capacity published on the website, what was this, 8 tons per day per module? I'm guessing that's based on something simple like a woody feedstock. Certainly if it's a high ash feedstock that's a little more, dense because of the inorganic content, that's probably going to increase. What feedstocks are your systems most suited to? Any. What feedstock limitations do you have as far as moisture, particle size, and ash content? I mean, it sounds like really none, but it's, correct me if I'm wrong, it's just a matter of there being enough energy in the feedstock, meaning enough organic matter to deal with the moisture content of the feedstock, yeah?
Yeah, that's correct. And actually, it really depends on the business model of our clients. Maybe someone's already interested in using the biochar concentration for soil amendment, trying to sell just biochar. And also, other clients are requesting for a carbon product that is able to sequester a lot of carbon. And yes, Diego also said maybe clients that are requesting just for waste heat. So yeah, there's a lot of revenue streams that we can have from the biochar production unit that we manufacture in our ARTi.
Neato. So then, okay, so it sounds like super flexible system. That's been the theme of this interview, it sounds like. So are there any limitations? Can these units be located in the middle of a highly populated urban area? I mean, that would be super challenging, right? What sort of inputs other than feedstock are required? Maybe a little bit of natural gas to get things kick-started or some fuel to get things kick-started. I'm asking too many questions here. Sorry.
For sure, Akio. So let me get that as well. So for us, all locations are potentially optimal, right?
I like to hear that.
We do have some requirements, yes. So, for example, we recommend some concrete padding to keep the unit level, for example. We need a power supply and also water supply, for example. On the side of internet, yes, we need internet, and we do recommend. So it's not absolutely a must, but we do use internet because our unit is completely automated. So the main idea is that you can control it anywhere. And we can also help you guys on that side to your clients. me monitoring the unit live with our engineers. So that's a great advantage that we have on the location of the reactor and also on the automation side of it. We'd also recommend like putting it closely to the feedstock that you are using. The main idea is also to mitigate this carbon footprint and avoid emissions, for example, from transportation, saying so. So if you move that equipment close to the feedstock instead of moving the feedstock to a big facility, it makes much more sense placing the unit near to your operation. And also it definitely has some significant cost reductions on that side.
Makes perfect sense. Well, so now I'm on to my, what is the scope of supply group of questions, but I think we've touched on everything. So I'm going to summarize what I remember, and please jump in if I'm getting something wrong here, okay? It sounds like, yes, there is consultation prior to purchase to investigate feasibility of the feedstock and operating conditions for a particular biochar product. Included in the hardware package are whatever is necessary for feedstock pre-processing, like drying or grinding. And this also includes biochar packaging hardware. And because it's a containerized unit that has already been commissioned at your facility, there's a minimal amount of, I guess, on-site construction requirements other than the concrete pad that you mentioned and provision for power supply and internet. I'm a little sorry to hear that, by the way, as a side note. Would have been cool to have one of these in my backyard, except for my internet situation at home is just terrible. Anyway, so regarding the scope of the supply, what did I miss? Anything?
Our proposal is also developing a complete system for biochar productions. Okay, so I am going to tell you a summarize of the process that we usually recommend to our clients. Okay, so it's important to emphasize that these are not obligatory steps. Okay, so we always recommend to our clients to start with the research and development projects to get the right parameters for the biochar production. Okay, so first of all, we start with a small-scale trial. So the objective here is to understand your biomass properties and the carbon products desired to produce. Okay, and then we perform a large-scale trial. So here we pyrolyze your sample in a real reactor. So we will know the pyrolysis conditions of your biomass. And also we develop techno-economical analysis as well. So we also perform a techno-economical to assess the economical performance of your project and the carbon dioxide accounting of your particular projects through a life cycle assessment. We also perform LCAs. And then we design, develop, and manufacture your reactor based on your needs. Yeah, that's what ARTi does.
I'm impressed, guys. That's really cool. I'd love to ask some question like, so what does it cost? But that's probably really difficult to answer because there's so many variables for this hardware package. Could you is there like a range? Like from super simple to, I don't know, the most ridiculously complicated scenario that you've encountered, what the installation cost is?
Yeah, for sure. Let me jump in. So with our single scale reactor that we have, that is one train, actually starts from the $500,000, and our biggest unit starts on the $1 million. So just our top numbers that we can give you, it really depends on the automation levels, the additional equipment that you require, and also the resizing based on your needs.
Yeah, that's not as crazy a range as I was expecting, somewhere between 500,000 and double that. I'm curious about, okay, all of these questions are difficult to answer because of the potentially the flexibility of the systems and the feedstocks and locations and so on and so on. But as far as the regulatory side of things is concerned, what sort of permitting or environmental monitoring requirements have you had to deal with as regards installation?
For sure, Akio. So on that side, there will be the correct answer would be depends. It actually depends on the location, depends on the feedstock, depends on the sizing of the reactor, lots of things. And also it's a new technology, right?
Yeah.
On the side of restrictions of environmental impacts, maybe, no, we haven't seen those restrictions, although we have seen some regions that are more stringent than others. So although our system is pretty clean as a new technology, we usually work closely with our clients and even with the local authorities, the environmental agencies. So we do have designed additional equipment to reduce this impact even further, to control emissions and be able to operate under these tougher locations, saying so. But the real challenge, as I said, is where there are locations where no regulation for pyrolyzers is in place. So you kind of need to construct that regulation with authority, but it's an advantage on our side that you will be the pioneer on that side.
Mm-hmm.
We get that big advantage with our clients, and kind of developing this is kind of also on our side and in the industry of the biochar side, starting to develop all the regulatory permissions, kind of laws to test correctly the system, because the system sometimes falls into other areas that has nothing to do with them.
And it sure sounds like that ARTi will be engaging in these regulatory conversations with whatever agencies are involved on behalf of your clients.
Yes, that's correct. We work closely with them and with the local authority. That's the main message, to make sure that the project is feasible and is successful for us all.
That's excellent. Really good to hear. I mean, always better to not reinvent the wheel, or allow the experts to do what they're experts at. And I could see that getting very cloudy in the regulatory realm. So it's good to hear that you guys take that on. I think finally, let's say somebody's just ready to go. What steps would you suggest to any interested parties? Who do they contact first?
So we are going to their point of contact. So we are going to suggest the next steps, as I mentioned before. So if the client doesn't know, I don't know, about their feedstock, the moisture content, other feedstock, of the particle size, we are going to develop research and development projects. Okay. And we always suggest, and as Diego mentioned, we work closely with our clients to suit their needs, always.
Well, you make it sound so easy. I think, no, I need to find myself a pile of biomass. That's what I need to do. Well, I would just like to say, I think this has been inspirational. Again, you make it seem so easy. Really cool to hear about this. I love modular design just as a concept, and I've been in love with shipping containers for quite some time. So the ARTi product really pushes a lot of my buttons here. At this point, I'd like to open this up to you guys. I'm curious if there's something that's nagging at you that you just have to get off your chest. Some questions that I didn't ask. Yeah. Okay. Over to you guys.
I would take the opportunity now to kind of reinforce some of the concepts of our industry and why we think it's so important what we are doing. But for example, I don't know, if I'm an audience, it's probably not very clear how biochar sequester carbon. That for me is one of the most outstanding concepts and technologies that we're developing, and people. Well, first, people to understand carbon as a currency, like what we're trying to do now, is like, well, you're going to buy a product and you're going to say, well, I'm paying this much, but also there's this associated carbon burden in that, Great, that's a concept that needs to be explained thoroughly because it's not easy. Well, now we're going into the biochar world, and then we're saying all these claims like, well, we are sequestering this much carbon. Wow, and that is really hard, to understand. So, first of all, we go to the big picture. We have been putting CO2 in the atmosphere since the Industrial Revolution, right? The levels of CO2 was roughly 280 parts per million. What we have today, it's 400 and something. 400 doesn't look much, but it's a lot. And also, that's what it's in the air. We have been putting CO2 or modifying ecosystems all over the world. So the problem is there. We have been burning fossil fuels, creating CO2, increasing that CO2 everywhere. That's a big problem. And why we are saying that this is such a wonderful technology, how are we sequestering so much carbon? It's the plant. The plant grows, absorbs the CO2 from the air, turns it into the biomass, into the plant tissue. And when you pyrolyze it, you cook it at high temperatures, then that carbon, now it's locked, it's fixed, it's sequestered in the biochar. And that is the sequestration. The sequestration is done by the plant. What we do with our technology is fix it, right? So now it cannot be broken down. Microbes cannot break it down. And now you put it in the soil and stays hundreds to thousands of years. So I try to explain it without too many technical words because we lose them. It's very hard, the concept. I mean, it is very hard. So yeah, long story short, there's a lot of CO2. Every year the plants grow. We pyrolyze them, and instead of decomposing back into CO2 when they die, we're locking into the biochar. And that's a sequestration. That's a holy grail. That's how I would approach it.
And, of course, all of the ancillary benefits to soil fertility and, the knock-on effects of increased standing biomass and the healthier soils with a better water release curve and less fertilizer required because the biochar holds onto it, and then fewer nitrous oxide emissions because that's also a potent greenhouse gas, go figure. Yeah, that's why we're here, or at least that's why we're here for this podcast.
So yes, you can modify the pH to a better range. Excellent. You improve the structure of the soil. And I don't think we grasp how important that concept is.
Also, we are doing an improvement in crop yields, and due to soil chemical, physical, and biological improvements. And also due to photosynthesis, we will be removing CO2, as you mentioned, Bernie, from the atmosphere, and other greenhouse gases as well.
But again, don't forget, if we do the right biochar, we increase the yields, right? That is huge. So we need to do the right biochar for that soil, for that crop, for that environment. That is huge. That is in economic terms a lot of money. That's what our clients are paying us for, right? Carbon sequestration, if you put it in economic terms, carbon sequestration now could be very close. It's a lot of money. The soil, the sustainability that goes, in the soil, the improvements of sustainability from nutrient retention, which means less leaching, you're losing less nutrients, you're contaminating less the groundwater, the lakes, right? The volatilization of some of the nutrients that happen, structural in the soil, physical, chemical improvements of the soils, absolutely. You are creating pockets of development, of enterprises and economic development in different places. How nice is to see the biomass processing facility all over the Midwest, where you need all these jobs. So, in a decentralized operation, obviously CO2, what else? All that stuff. And the other benefit that we also have is in many of the models that we're doing, actually the tipping fee, right? So you have something that is problematic. It's not in the right location in the right time. And then you have all this biomass that it can be turned into a product. But it could be a nuisance, right? So those, I mean, economic activities around the pyrolysis platforms are all over. So all our clients are different. And the benefits, the number of benefits that we need to match. There's obviously tons more, but I think that's a pretty good idea of why biochar is going to save the world, right? So anyway, any other question, any other comment?
I mean, none from my end. Yeah. So on that note, I'd like to say thank you so very much, Bernie and Diego and Melanie and Lizette from ARTi for joining us today for the Biochar Technology Podcast. This has been great. I've learned a lot. I want one.